Have you ever wondered if time as we understand it truly exists? This question might seem puzzling at first, but it unravels a profound paradox that has intrigued philosophers, scientists, and thinkers throughout history. Time is a constant in our lives. From the moment we wake up to the moment we lay our heads down to sleep, we're bound by the ticking clock. It governs our routines, our work, our leisure, and even our biological processes. But despite its omnipresence, time remains an abstract, intangible concept. You can't see it, touch it, or hold it in your hand. It's like a phantom, always there and yet not there at all. This is the paradox of time. It feels so real, so concrete, yet it slips through our fingers like grains of sand. We measure it, live by it, but can never truly grasp it. It's like a river, constantly flowing, yet never the same. You can't step into the same river twice, as the ancient philosopher Heraclitus once said, and so it is with time. But perhaps what makes time even more paradoxical is its relativity. Enter Albert Einstein, the brilliant physicist who suggested that time is not as absolute as we might think. According to his theory of relativity, time can stretch and shrink depending on the speed at which you're moving and the gravitational field you're in. A minute on Jupiter is not the same as a minute on Earth. A year traveling near the speed of light is not the same as a year sitting at your desk. Time, it seems, is not a steady, unchanging entity, but a flexible, malleable construct that bends and warps according to the laws of physics. So, if time is not absolute, could it be possible that time does not exist at all? This is a mind-bending thought, one that challenges our very perception of reality, but hold on to your seats because we're just getting started. In the next scenes, we'll delve deeper into the illusion of time, plot it on a graph, examine its nature, and explore the implications of a timeless universe. Stay tuned, because this journey through time is about to get even more fascinating. What if time is merely an illusion, a construct of the human mind? It's a tantalizing proposition, isn't it? Let's venture into the realm of the abstract, the domain of our perceptions. We perceive time as a stream flowing from the past, through the present and into the future. Yet this perception is created by our brains, the most complex and mysterious part of our bodies. Our brains process information from our senses and create a cohesive narrative. This narrative includes the concept of time, which allows us to make sense of the world around us. But what if this narrative is not entirely accurate? What if the concept of time is merely a cognitive tool, a framework that our brains use to organize information? Consider this. When you recall a memory, your brain is not actually traveling back in time. Instead, it's accessing information that was stored in the past. Similarly, when you think about the future, your brain is not actually peering into the yet to come. It's merely using past experiences and current information to predict what might happen. This suggests that time as we understand it may not exist outside of our minds. It's an integral part of how we perceive and interact with the universe, but it might not be a fundamental aspect of the universe itself. Physics too hints at the illusion of time. In the realm of quantum mechanics, time seems to lose its arrow. Particles can exist in a superposition of states, seemingly defying the forward march of time. And in the theory of relativity, time is intertwined with space, creating a four-dimensional fabric called space-time. But space-time is not flowing or moving, it simply exists. So we find ourselves in a curious predicament. Our everyday experiences and the laws of physics seem to tell different stories about the nature of time. If time is an illusion, then how can we explain its apparent flow? It's a question that continues to puzzle scientists and philosophers alike. As we delve deeper into the nature of the universe, we may find that our understanding of time is due for a radical overhaul. Imagine plotting time on a graph. What would it look like? It's a fascinating question, isn't it? We're used to seeing the flow of time as something constant, something unstoppable. But what if we took a step back and looked at it from a different perspective? Suppose we represent time as a horizontal axis on a graph. Every point on this axis corresponds to a specific moment. Now, if we were to plot the entirety of time, from the past to the future, we would end up with a static image. From the Big Bang to the end of the universe, everything would be there all at once. It's a peculiar thought, isn't it? This static image contradicts our everyday experience of time. We perceive time as something that's always moving forward, something that's always changing. But on our graph, time is not moving at all. It's not flowing, it's just there, all of it, at once. This brings us to a rather mind-bending conclusion. Time, as we perceive it, does not exist. It's an illusion, it's a construct of our minds, created to make sense of the world around us. But in reality, all moments exist simultaneously. So why do we perceive time as something that flows from the past to the future? It's a complex question, one that involves our perception, our consciousness, and the laws of physics. But that's a topic for another time. For now, let's just marvel at the paradox that our graph represents. Time, despite its ubiquity in our lives, remains one of the most mysterious concepts in science. It's something we all experience, yet it's something we don't fully understand. And perhaps we never will. But isn't that what makes it so fascinating? Isn't that what makes us want to learn more, to dig deeper, to unravel the mysteries of the universe? This graph shows that time, as we perceive it, does not exist. But then, what is time? If time is not what we perceive it to be, then what is it? Dive with me into the realm of theoretical physics, where the nature of time is a subject of intense debate. Here, time is often seen not as a linear path from past to future, but as a dimension, much like the three spatial dimensions we are familiar with: length, width, and height. Imagine a universe where time is a landscape, a topography we navigate just as we traverse the physical world. In this universe, the past, present, and future coexist not as distinct entities, but as coordinates on a map of space-time. This is the concept of the block universe, a cornerstone of Einstein's theory of relativity. Yet this doesn't resonate with our everyday experience of time, does it? We perceive time as a relentless river, flowing from the past, through the present, and into the future. This perception has led some to suggest that time is not an inherent aspect of the universe, but rather a human construct, a tool we've devised to make sense of our existence. Consider the second law of thermodynamics, which states that entropy or disorder in the universe always increases. This law gives us a sense of direction, a way to distinguish past from future. But is this a fundamental law of the universe, or simply a reflection of our need for order and predictability? Think about it. We measure time in seconds, minutes, hours. We divide it into days, weeks, months, and years. We mark the passage of time with birthdays, anniversaries, seasons. But these are all human constructs, aren't they? They are ways we've developed to understand and organize our world, to bring some semblance of order to the chaos. So time may be nothing more than a dimension or a human construct. But what does this mean for us? In the grand scheme of the universe, the nature of time might seem esoteric, abstract, yet it is an integral part of our reality, shaping our perceptions, our experiences, our very existence. So join us as we continue to explore the fascinating world of time in our next segment. What would a universe without time look like? It's a question that might seem unimaginable, but let's delve into it together. In a timeless universe, the traditional concepts of past, present, and future would be rendered meaningless. Everything would simply be. There would be no before, no after, just a constant state of now. This might sound fantastical, but it's a concept that has been seriously considered by various physicists and philosophers. The implications of such a universe are profound and far-reaching. It challenges our understanding of the universe and our place in it. In a timeless universe, cause and effect would cease to exist. The very notion of causality hinges on the concept of time, on the idea that one event precedes another. But in a universe without time, what we perceive as cause and effect would be unrecognizable. Every event would simply be with no clear beginning or end. This also impacts our understanding of space. In Einstein's theory of relativity, time is intertwined with space, forming a four-dimensional fabric known as space-time. But if time does not exist, then space-time as we know it would be fundamentally altered. We would need to rethink our understanding of space itself. On a philosophical level, a timeless universe raises intriguing questions about existence and consciousness. If there is no past or future, does life lose its meaning? Or does it gain a new one? Without the march of time, is change possible? These are not easy questions, and they don't have easy answers. But they push boundaries and challenge us to think beyond our conventional understanding of the universe. In a universe without time, our understanding of existence itself would be fundamentally altered. Indeed, the implications of a timeless universe are as fascinating as they are complex, compelling us to continue exploring the mysteries of our universe and our place within it.